that honestly, if Georgia State had
All right, ready for some more practice?
I would probably stoop that low. That one also. I already stooped basically.
Here we go, let's have some questions. What do we have? Whoops, I'm all over the place. Okay, Sarah.
1.71 on the review sheet.
Number 1 to 1.7. So here we go. Okay, so I want the end behavior asymptote. See how these powers match? So my end behavior asymptote is horizontal. It's y equals 3 fifths. That's it. As we go off the page, we get closer and closer to 3 fifths.
The 2's had homework, then like anywhere like 7 through 10.
Skip 1.
8.
210 homework. Number 8. Well, you need to use your graph. So the exponential y equals a to the x was sketched for you on here. And so then you were doing the inverse, which would be y equals log base a of x. That would be the inverse function. So when it says, number 8 says, find log base a of 1/2, that means I'm over here where x is a half, right? And what's your y value? What's the value where x is a half? Well, on mine, it's approximately -2. -2. But yours could be a little different depending on how careful you are. But yeah, that's what you're doing. Yeah.
For that same one on 6, what would the inverse line be?
The original is this. Okay, so keep in mind that when the original was this, asymptote, so the asymptote of the original was negative x-axis. So when you reverse the variables, it's going to be negative y-axis. Where's the asymptote of this? That is not the y-axis, that's the positive x-axis. So its asymptote is going to be the positive y-axis. Now, also keep in mind the nose is flip-flop the ordered pairs. So whatever, pick some ordered pairs on the original and plot the ordered pairs. Okay, what else? Marion?
It was 2.12 once.
2.12. 1C. Minus 1. Now remember, 1 is the log base 5 of 5. And since I'm supposed to be combining all of these, it's probably best to write it as a logarithm so that it can be put together with, is that my job? Yeah, put together with all of these. So it's going to be the log base 5. 3 times 12y. Okay, who else?
1.7 on the review sheet questions.
1.7, question 2, which is another end behavior. Now the powers don't match. The one on the bottom is bigger, so the behavior asymptote is a horizontal line at 0. If the power on top is bigger, then you have to divide and find the slant aspect. But in this case, you don't need to, it's just 0. Okay, what else?
On the review, 2-6, number 1.
2, 6. Number 1. Identify A and B as linear, quadratic, exponential using a scatter plot. So, I mean, having some kind of graph paper is better, but a scatter plot is just plot those points and then see what kind of shape they look like they're in. They're not gonna be exact, but if the points are all lying in generally a straight line, then it's linear.
Do we use that plot that's next to it, or do we?
No, that's another problem, that's number 2. That's number 2. So just get yourself a piece of graph paper or use, I included some graph paper in the review thing. Plot those points and see what shape you get. So you have to know that if it's linear, they'll be in a line. If it's some kind of parabola, it won't be exact, but if it's that kind of shape, it's quadratic. If it's this kind of shape, it's exponential. Yeah, just plot those points and see. But it really needs to be on graph paper. Jax, your hand up?
No.
Then quit scratching your head. Alright, who else has a question?
2-8 on the review,
2, 8. Number 2. Prove that these are inverses. How do we prove that things are inverses?
2. Put y in the x box.
No. How do we prove, not find inverses? How do we prove they're inverses?
So were you like plug into the
We build them in composition. So in other words, you plug G into F, and it has to equal X, and you plug F into G, and it also has to equal X. So it's a 2-step process. So, what are my functions? Yes. We call it 2, 8. So my functions are these. Okay, so I'll do this one first. I'm going to plug G into F. So put it in right there. So I have 1 over 1 minus 2x over x plus 2. Now I gotta simplify that, and hopefully I won't have anything left but x. So let's see, you can do this however you want. I'm gonna times everything by x, because that'll get rid of that denominator. So now I have x over 1 minus 2x plus 2x, which is x over 1, which is x. Okay, good. Now I gotta do that one, which says plug F into G. So it's gonna go in here and here.
And you want it to be negative x?
No, it wants to be X.
Oh.
Look. So 1 minus 2 becomes 1 over x plus 2 over 1 over x plus 2. Now you can clean that up any way you want. I think I'll just multiply by x plus 2. So I have x plus 2 minus 2 over 1. There it is. So they are indeed inverses.
How do we write the proof statement?
That you don't have to write, well, you can conclude it and say, because that equals x and that equals x, f and g are inverses. That's probably a good idea. That's how you prove things are inverses. Okay, what else? Who else has a question from something somewhere?
2.4 on the review question one.
Which one?
The review, 2.4 question one.
One. Okay, so we need to recognize, well, first of all, what does it mean to be a horizontal translation?
Changing the X.
Not just a change in the x, but adding or subtracting to the x, right? So when you look at this equation, it is very obvious we had a translation, right? What's happened? It's been moved 2 units to the right. Now, you want to come up with the same exponential, but you don't want it to have a horizontal translation in it. So remember that this thing can be rewritten as 3 to the x times 3 to the negative second. Because when these are multiplied, their exponents are added. Well, what's 3 to the negative second?
1/9.
So this is 2/9 times 3 to the x. So it is the exact same function, but now it's written with no horizontal translation. What is this? A vertical dilation. Remember, that's how you, when you multiply by something, that's a vertical stretch or shrink, right? Out here, when you multiply out here.
And that would be normal, but if it was in the x, then it would be like a fraction.
I don't know what you mean.
Like that's 2/9, but if it was 2/9 in the next to the x, it'd be 9/2.
Yes, the dilation factor would be that, yes, yes. Yep. All right, what else do we have?
Is there any hard ones on the review? That you know of?
Austin?
Can we get a refresher on the instantaneous rate of change? The
Yeah.
1.2 for what?
1.2.
Or
1.2, number 4. Now, if I said to you, well, first of all, let me preface this by saying, in calculus class, you are going to learn how to do instantaneous rate of change in a snap of a finger. Okay, just a boom, you got it. We're not there yet. So, we're going to think about instantaneous rate of change like this. If you took the function, this function right here, and I said to you, find the average rate of change on the interval from 1.9 to 2.1, could you do that? Absolutely you could, right? Well, what if I said, find the average rate of change from 1.99 to 2.01, could you do that? Okay, now, what happened here? What happened? It got, so if I'm 2, in this one, you're doing the average rate of change from here to here. In this one, you're doing the average rate of change from here to here. Well, what if we did 1.999, 2.001? Now we're finding the average rate of change here. So are we getting closer to the actual change at 2?
Yeah.
Now, we this procedure, the actual rate of change at 2, because we need two numbers. We need to do f of b minus f of a, right? That's how we find our rates of change. But if we get really close, and you can get as close as you want, so you could do 1.999. I mean, I would at least go this far, but then you can even get closer to 2, and that will approximate the rate of change. So what we do again, go back to your function, and you would find g of whatever number, like 2.01 minus g of 1.999, and divide that by 2.01 minus 1.999. You would actually find the rate of change using these numbers that you have squeezed in on. Now, disclaimer, Ms. Ford did not plan this problem very well, because the rate of change is actually going to be 0. That happened because I should have made that a 3, and I didn't. I wasn't thinking ahead enough. So, don't panic when you get 0. This is just going to work out to be 0. And that's okay in this problem. Normally it won't. It just, I got lucky. I'm lucky.
Do we have to do the first two or just
No.
skip through?
This was my illustration. No, you have to do this one or one beyond it. Okay, since we're rounding to the nearest thousand, I would say this would be the very minimum that you could do. But the closer you get to 2, the more accurate that answer is going to be. Okay? All right, good question. What else? Morgan?
This is like a question about itself. So on the first one's questions, is it like this to show like super detailed work to get all 18 points?
You have to, the general rule of thumb is your reader has to understand what's going on. And you should assume that your reader isn't a gifted mathematician. Actually, that's not an assumption. I'm your reader, I'm not a gifted mathematician. So you have to explain what you're doing, okay? I mean, you don't have to say things like, since 1 plus 1 is 2, I mean, that kind of stuff you don't have to do, but you should show as much as you possibly can. Yep,
Can you do 1.5, question 6 on the review?
question 6.
I just need a brief.
Prove even, odd, or neither. So this is kind of like when you were proving things were inverses. How do we prove that something is even, odd, or neither?
It's to the highest power.
And no! I mean, you can put that, but wrong. Okay? Now, sometimes that will be fine, but that is not the proof. How do you prove that something is even? If something is even, then a of negative x has to be the same as a of x. That's the definition of even, and that's how you prove it. If something is odd, then a of negative x is negative a of x. That's odd. Those are the definitions of being an even and an odd function. Okay? Now, this one is going to work out to be even, but if I put a 5x here, now it's not even anymore, but nor is it odd. So don't just look at the problem. Work it out if you are asked to do a proof. So, what's a of negative x? That's really what it all hinges on. What is a of negative x? 2 times negative x to the 4 minus 3 times negative x squared plus 5, which is 2x to the 4 minus 3x squared plus 5. Well, wait a second. Isn't that the same as the original problem? Therefore, a is even.
If you plug in a negative, you get the same x if you plug in a positive. That's awesome.
So what did you, like, did you not, do you multiply the 2 by the negative x? Oh, never mind.
Negative x to the 4th is x to the 4th times 2. Alright, what else? Homework, review sheet. What have we got? Alright, let's look at the back of the last page, the page before the back, where it says exam review extras. I remember back in the beginning, this kind of thing, like number 1, drove us absolutely insane. We were missing stuff left and right. Let's see if we have it figured out now. So look at the graph of F. Would you say that the graph of F is positive or negative? Positive. Boys and girls, a function is positive if it is above the x-axis.
What number is it?
Is it increasing or decreasing, the graph? Increasing or decreasing? Decreasing. It's going down. That is decreasing. The rate of change is positive or negative? Negative. Negative. Kids, what is slope? Slope is rate of change, right? What's the slope of that curve? I'm using the word slope.
Negative.
Yeah, it's definitely negative, right? So the rate of change is negative. Is the rate of change increasing or decreasing? Increasing because we are concave up. So all of that stuff, you have to read it very carefully. All right, let's look at the second one. The graph of G is negative. It's below the x-axis. It's negative. The graph of G is increasing. Isn't it going up?
Yeah.
The rate of change is positive. It's going up. The rate of change is increasing or decreasing?
Decreasing.
Decreasing because it's concave down. And then let's look at H. Positive or negative?
Positive.
The function is positive. The function is positive because it is above the x-axis. All of the y values are positive. Is the graph of H increasing or decreasing?
Decreasing.
Decreasing, and therefore its rate of change is negative. Is the rate of change increasing or decreasing? Decreasing because it's concave down. Okay? Take your time on those questions. Those are good multiple choice type questions. All right, what else?
4.7 review, question 2.
1.7,
Or, I'm sorry, 2.7.
2.7,
Question
2.7, question 2. All right, 2.7, question 2 says find the composition G of f of 2. So f is the function this. And then G, I don't have a definition for, but I have a table for it. So, what is f of 2? F of 2 would be 1. So now I have to find G of 1. So I look at my table. If x is 1, G of x equals 3. So the answer to the problem is 3. Sometimes when we do that, you can't do the problem, right? So for example, if this had been a, let's say 5, then f of 5 is fine. F of 5 would be root 10. but I can't put root 10 into G because it's not there, yeah. So remember, that happens sometimes. All right, one more question. Somebody come up with one. Which one?
Could you do 113, 114, 1 and 2?
Let's look at one for, all right. Wait, which one are we doing?
113, 114, 113.
Okay, you just put it in your calculator,
Oh.
stat edit, and then stat calc, and do a linear regression model. And then do the same thing with the four of the other.
And then make a plot of the points above 0.
And with your calculator, you can get it.
To get your calculator to do it for you, once you get that, you plug it in like at 5, like when you put the residual, how do you get that feedback?
You need to bring your calculator. Okay, that didn't count as a question, so I need another question. Obviously, you need to practice with your calculator.
213, number 6.
213. Number 6. Okay, Brayden, what's your question here?
So like after we get that, we do the plug and check for the first part. For the second part to check if it works in a log, we say equal to
X has to be bigger than 3/2. X has to be bigger than -4. And X has to be bigger than -1/4.
And when we do that for inequalities, will it always be X is bigger than, like X has to
Okay, now
be
stop. Stop. We're not memorizing that.
Okay.
What do we know about taking the logarithm of something? It has to be positive. It's positive. Now, this is not an inequality, but this one you can understand. The equation itself. These are always going to be greater than, they have to be bigger than 0. Okay? So this is going to be an equals. You're going to solve this, it's going to be a quadratic equation. You're going to get a couple of answers. They have to fit all of this. So basically, they have to be bigger than 3/2. So whatever answers you get, x equals 5, x equals 1/2, or whatever, they have to be bigger than 3/2. Right? All right, we have one more review, boys and girls. I need you to come better prepared than you came today, okay?
This is for, judgment for also to figure out how to.
Yeah.